So the second example is a slope that titled Simple Slope in Hook and Brown material that is available in help of version 9. So this slope is performed in two material cases. So the first one is Hook and Brown material, and the second is Hook and Brown material and more Coulomb layer in here. So, it's compared with the limit equilibrium methods. Let's get start the full explanation from the help of software. So, open FLAC3D version 9, then close this window. From here, you can from here you can overhelp and click examples from here, examples. Then a window will be open. You can check FLAC3D. So, and you can write at search a slope, then enter. From here, simple slope in Hook and Brown materials FLAC3D. So also from this window, select FLAC3D from drop down. If not selected, you can select FLAC calculation method or calculation program. Then click OK to open the example. So before explaining the FLAC model or code, let's read the software help and the article related to this example from the screen. Click and press F1 to open open help, and then by this icon opening the default browser, you can see the help of version 9. So I find the model in the software help, then description of them. From here, modeling methodology. So in the factor of safety, if I see them, it's factor of safety. So a structure, then we can find it. So software guide, factor of safety, and then in example factor of safety for this one in FLAC3D, and then simple slope in Hook and Brown material for FLAC3D. So the full description and detail of this example from here. Simple slope in Hook and Brown material FLAC3D. Problem statement is verification exercise are performed to the validated factor of safety calculation using Hook and Brown material in FLAC3D. The exercise tests the strain reduction calculation based on open shear strain top. Then the factor of safety with respect of Hook and Brown shear strain is calculated for simple slope geometry and compared to the result based upon or method calculation factor of safety for Hook and Brown material. So it's generalized Hook and Brown method for calculating factor of safety for Hook and Brown, equivalent more Coulomb and Bishop and Spencer limit equilibrium method. Also, there are some methods for limit equilibrium method, but just compare with Bishop and Spencer from here. Reported by Hammer ITRA 255. The rock slope for this comparison calculation has a limitation of 40 45 degree and the height of 10 meter. The rock is represented in Hook and Brown material with the following properties. So the property is are here. So the simplest slope, it's the first example, first slope, and then there is a factor of safety, also zone maximum shear strain increment. So also there is example two from but by a material Hook and Brown and a layer in this area. So the references of this example also it's from Emma by the name titled the shear strain reduction method for the generalized Hook and Brown criteria. It's for ARMA. Also, there is a paper for it. So it's a paper. So for abstract of this paper is this paper describes a method that allows this direct use of the generalized Hook and Brown criteria in a finite element. It's full finite element by rock science, but it's not limited just for FE. Shear strain reduction, in short SSR. Analysis of rock slope, it describes the generation of the shear evolve for the Cretaceous. So it's abstract of this example. You can read, and also there is an overview of the shear strain reduction method. You can read three steps of the SSR. Also, SSR it's like this, and there is a formulation of FE slope stability for generalized Hook and Brown. For example, axial compression strength, it's a equation of it, and material intact rock material property for Hook and Brown. Also sigma n, it's normal stress and shear stress and normal stress. So and there is a estimating of parameter for reduction shear strain eval, and also there is a step for estimating the generalized Hook and Brown parameters after reduction shear eval. Then as follow: establish the range of minor principal stresses acting to the slope since the minimum stresses is taken to the tensile strength sigma t. It is only necessary to determine the maximum sigma 3 value in the slope, determine the corresponding value of the normal stresses sigma and max using equation 5 as mentioned in as before. Minimize the squared error function over the range. So minimum square error function also there is in the here is it's for maximum error equation squared error function. So the property of this example also in table 1, the shape, the geometry of a slope example, it's from here, and also for example 2, its geometry, and the comparison of factor of safety result for example 1 for FE SSR technique Q, it's true value, more Coulomb and Hook and Brown, and also limit equilibrium for Bishop and sponsors methods is equal this. So for second example, also there is a comparison of factor of safety result. This is a result, and let me come back to the FLAC and explain the code and model. So We had a description of the user interface in the first chapter. On the left side, we have project panes. So you can active and deactive by clicking. Also, workspace for manage the view plot, coding, and controlling the editors, and also the command for control the console, Python, fish symbol, and Python and fish symbol. Also listing pane. So uh, you can control the all of panes, all of window by moving this control, and double click on the I double click on the master uh, for see the management for see the all of the phase on the in this example on this model. Uh, the master file represent the management and the phases of your model. If you are a designer, it's better to call the codes you write in with the file by master file, so that someone who wants to check your codes can easily find the order. Here the order of phases written meaning. The first one is Hocken-Brown slope. The second is Hocken-Brown slope 2, and finally and third phase is check. So I execute the model with this icon. The all of phase will be open, will be execute, and the model is run. As order, we have this order. First is Hocken-Brown slope, then we have Hocken-Brown slope 2 and check. Uh, from this section, we can check. We can active the plots. The first, for example, you can grid by double clicking. This is active, and you can active control panel by this icon, and then by this icon you can see help, fish symbol, and viewport, and control panel of the view activate. The value of the behavior of model, it's from here. For example, zone in this material of the grid, it's a grid for this example, the first example, and material from here, zone material. You can click on this this item. You can deactive or off the command by clicking to see better than the control panel. By clicking zone model, you can see the zone model Hocken-Brown on constant and more column. Also, you can change the value to see by drop down by selecting on this drop down for counter or label. I choose the property from this drop down list, for example property, and then by clicking, for example, equation. For example, you can select another property that describe this for the constitutive model that we assign the property. So there are another property by this list, for example, for Hocken-Brown, and constant S, constant A, for it's for Hocken-Brown. As you see, you can see the Hocken-Brown constant A for current for Hocken-Brown, and it's NA. It means there isn't this parameter for this constitutive model. Also, you can click this plot. It's for FOS plot. You can see the uh, plot of FOS. The value of FOS is here, and also the contours for zone maximum shear strain increment by this legend. So the model completed. Open again master. In the first phase is Hook and Brown slope. I open it and description for this example. So the first in the line 1, 2, line 3, there are some information. As mentioned by semicolon, it's not execution by the FLAC. The first code in line 4, it's model new. By this line code, the clear all of executed code as before this line. Model larger string off, it means the calculation for mechanical is done by smaller string. So the first step for this simulation is geometry. So for geometry, the zone create break by point 0, point 1, point 2, point 3, and the size for x direction, y, and z direction. It is it's created by two block in the grid. It's one grid and two grid for you can check it by changing this the slot from here. So label group, and then there are two break one and break two. So in the next of this code, there is a zone face skin. It's for skinning and grouping name boundaries around the model, and there is a assigning constitutive model. It's Hook and Brown for first example, and there is a property of this Hook and Brown: density, Young, position, tension, constant, MB, S, A, and SCI. Although there are two flag for flag FOS 0 and flag evaluation. So it's if it's for 0, it's calculation for shear strain. Also, if it's 1, it's for compression, axial compression stress result. For boundary condition, there is 4-5 line code for applying velocity normal to face around the model, and there is a model gravity from here, which is for setting, and also there is a after that we can save it the execution code by names initial. It's from here, initial save, and by the model factor of safety bracket from 1.1 to 1.2, convergence 1, file name HB slope. It means calculate and execute the model for factor of safety between bracket for a factor of safety from between 1.1 to 1.2. It's limited to searching factor of safety between two value, and for convergence criteria by convergence 1. There are some methods for checking convergence of calculation and model for FLAC3D. This is a method for convergence. It's equal 1. And the saved file by name HBS slope for stable and unstable. If you look at this, there are two value for HB slope unstable and HBS slope stable. It's for true value that's stable and unstable limit between true value. So after that we have model safe initial. Then the next phase is Ockham Brown for slope 2. So example 2, it's similar like this, like the first like first the like the first example, but there is a layer for material more column value. It's range group layer for properties and assign more column constitutive model, Young cohesion, constitutive cohesion, friction, and tension. And it's like to first example for boundary condition and gravity, and finally model factor of safety bracket 0.9 to 1, convergence 1, file name HBS slope 2. So there is two the safe state for stable and unstable also. There is a safe state 2 for this example. And finally, we have a check data file. It's for checking and plotting and export the plots we created before. You should create these plots from here by new plot, and you can also by right clicking on the screen of view and new plot, then select and fit the value plot item and the view shift, and also any detail you needed for this plot. Finally, you can export by graphical. For example, click right click on the screen and export and bitmap, or you can by code. It's for plotting, export plotting by name grid. There is a grid plot for by format bitmap file name HBS slope grid PNG. I'll be find in the explore. So there is a model restore initial. So plot the first model restore HB slope unstable. So sensitivity check minus test check reals this value and this value total tolerance 0.006. So it's this line code for checking or compare two value. The first value is global FOS. Global FOS as described it by FLAC3D. You can use this symbol or use this keyword fish keyword for getting forget or set the FOS. This is forget FOS that we executed as before, and this value is for user defined. You can change it. Tolerance between 0.006. This line code is for compare two value. If the tolerance between two value larger than this value, the system or the FLAC3D pop up an error to large tolerance of two value, and there is a plot for FOS export. Also, there is a test for example 2 by two value. The first one is and test check real global FOS 0.996, and this value. So for Windows and Linux calculation, and finally there is a plot FOS export bitmap file name this value by right clicking from here and showing Explorer. you can see the all of saved state and exported picture. So from here there are all of export file that I executed as before. So there is a one for FOS and also there is for FOS2. It's a Hook and Brown grid and it's first and two. So uh, the example two completed and you can look at another examples in help of this the example in help of FLAC3D version 9. You can select anyone you want to look or you want to learn and open it, and also you can read the description of the example in help. So this chapter is completed. Thank you for your attention. Good luck.